Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Engineering. So today's topic is transistor, that is BJT in equilibrium condition, that is no external bias and with biasing. So let us have a small recap about the previous portion. So in the previous class we have studied about the basics of BJT. What is BJT and what are the terminals? That is BJT, that is bipolar junction transistor. That is, bipolar means the flow of current is due to the both charge carriers, minority and majority carriers. So there are three terminals: emitter, base and collector, and there are two junctions, emitter base and emitter collector, and there are three modes of operation: active region and saturation region and cutoff region. So with this we are moving to the topic. So BJT in equilibrium. First we should know what is equilibrium, what is biasing. So equilibrium means no external bias. So no external bias is applied to either of a base emitter junction or base collector junctions. So what will happen? No external voltage means no current flow, because BJT is an active component. So active component requires external supplies for its operation. So with using this energy band diagram, we can say there is a smooth transition across emitter base and collector junctions. Both junctions are at their natural built-in potential, so no current would be flow in equilibrium condition. Next, biasing. So first we should know what is biasing. Biasing is the process of applying external supply to the transistor. It is mainly used to set the transistor in any of the region, that is any of the operating region, that is cutoff region or active region or saturation region. So here the symbol of BJT, that is B means base, E means emitter and collector. So emitter base ratio it is called beta, and emitter collector ratio it is called alpha. So the next one is biasing. Types of biasing. So there are 5 types of biasing: fixed bias, collector to base bias, fixed bias with emitter resistor, voltage divider bias or potential divider, and emitter bias. We will see one by one. First one is fixed bias. So it gives it is the simple circuit, but it gives poor thermal stability. Why it is called fixed bias means a base resistor, that is RB, is connected to the supply to set the constant base current. So it is simple but less thermal stability. So the next one is collector to base bias. So there is a resistor from collector to base bias provides negative feedback. Generally the negative feedback, that is feedback means connecting the small amount of output to the input, it is called feedback. So it gives the negative feedback, so it improves the stability and overall bias. So this is the circuit. So RB and RC is connected. And the next one is fixed bias with the emitter resistor. So there is a resistor connected in the emitter, that is RE. RE is connected. So the emitter resistor also gives the negative feedback. So obviously it improves the stability. So also it gives the good operating point against the temperature change. So voltage divider bias or potential divider. So here the two resistors R1 and R2 acts as a voltage divider. So two resistors it is mainly used for stable biasing. So it gives the also the emitter resistor also connected. So it improves the gain stability of the circuit. So the last one is emitter bias circuit. That is, here in the circuit base resistor connected, and emitter resistor also connected, and there is a small difference, that is both positive and negative supply is connected. Here the VCC is the positive supply and minus VE is the negative supply. It also gives better stability of the circuit. So these are the various types of biasing. So hope this video will help you to understand what is the equilibrium condition, what is meant by biasing, and what are the different types of biasing, what is negative feedback, and how it improves the gain of the system. So the questions are, what is equilibrium condition, list the types of biasing, and what is feedback, why the emitter base is used. So these are the questions. You students, please submit it on tomorrow. Thank you.